Okay, so the last kind of display for quantitative variables that we'll talk about will be a histogram. Also, histograms are probably equally as common for us in this course as dot plots are. So quantitative variables often take many values. A graph of the distribution could be more clearly if we group them together. Um, Often you could end up with a graph um, that it won't tell you much. It'll be an okay graph, but it's not going to mean much to you. Where if you grouped some values together, then it could make a more clear picture for you. So one very common graph of the distribution of a quantitative variable is a histogram, which does just that. Okay, so let's talk about how to make a histogram, and then we will actually make a histogram. So what we're going to want to do is divide the range of data into classes of equal width. Okay. So that would be kind of like intervals. So you're looking to say, am I going to do ages from 0 to 9 and then 10 to 19? And then if you were looking for, which age groups or which ages uh, uh, text message the most, okay? And then you would do something like, 10 to 19, 20 to 29. It might mean more to you to see it within a group. You may decide that your data, though, should be not such a big range. So you might want to do 10 to 14, 15 to 19, 20 to 24, and so on. That's up to you with how you want to do it. You There are some ways that are better than others, but we're going to rely on our calculator for that. I'm going to show you that in class, though. Okay, we should then find the count or frequency or percent of the individuals in each of those classes, so in each of those intervals that you set up. We're then going to label and scale your axes just the same as you would in any graph, okay? And then you're going to just draw out the histogram. Histogram, very much like a bar graph. The heights of the bars equal its frequency, okay? The big difference between a histogram and a bar graph, other than the fact that it's quantitative, not categorical, would of course be the idea that there's intervals down at the bottom. Adjacent bars should touch, okay? That's another big difference. A histogram, the bars are all touching, as opposed to a bar graph, they do not. Unless a class contains no individuals, okay? And then in which you would skip over because it's representing a 0 in that class, not that you skipped a space to leave space, okay? So, I said on page 35, but it's in your packet. So in your packet, I gave you a list of, let's see here. Okay, so residents born outside of the United States. Okay, so right here you have the breakdown of state by state. Okay, so I came up with this class. You can use the same as me. You can decide to do something a little bit different. I'm going to show you more when we get to class. I'm going to show you more on the calculator and the quickest way to decide how to kind of set these intervals, okay? So what I did was I set these classes or these intervals, okay? And then I just went through and I took a count, okay? And now I'm ready to go ahead and make a histogram, which is just going to be a bar graph essentially representing these. Okay, I need a bar at every height. These are like almost like your categories, only it's quantitative. So I don't want to call it categories, but that's kind of what they are. And then here's the bars, and they have to go to this height. Okay. Standard to go ahead and set your axes up like this. There is another way that you could do the bottom. I would show you that, but technology will do this. And then I just count them up, okay? And so this would be a histogram of that information that you guys have in that graph. Okay. So histograms can be trickier than you think, okay? So when we're creating histograms, we do want to be very, very careful of a few things, okay? What we're actually doing in a histogram is so we do want to make sure that we use our histograms wisely, okay? So here's a few kind of cautions to follow, okay? The first caution would be, don't confuse histograms with bar graphs, okay? Although histograms resemble bar graphs, their details and uses are very much different, okay? So biggest thing is probably what they display. Histogram displays quantitative as opposed to a bar graph that displays categorical. The horizontal axis of a histogram is also marked in the units of measurement for the variable. A bar graph would use to display the distribution, comparing sizes of different quantities. So you're looking at categories on the bottom. The horizontal axis, would be categories at the bottom. You draw bar graphs with blank spaces between, okay, where histograms would have no space, okay. For comparison, here would be an example, okay? So here's your actual variables down at the bottom here, okay, as opposed to these being categories, okay? The other idea would be that these are all together. There is a space here, but what that space is saying is that there is nobody from percent from 20 whatever it is to 25. That's 22 and a half to 25. That's representing nobody. It's not that that's a space, where these are spaced out. Another big thing would be to use percents instead of counts on the vertical axis when comparing distributions with different numbers of observations. So like here's, this kind of goes along with these two graphs. So if Mary was interested in comparing the reading levels of a medical journal and an airline magazine, okay, she counted the number of letters in the first 400 words of an article in the medical journal and of the first 100 words of an article in the airline magazine, okay? So here's two histograms below. The figure is misleading. It compares frequencies in this one right here in A, okay? This is comparing right here, this one. Okay, this is comparing frequencies, but the two samples were of very different sizes. So if you heard me, I said the one sample was 100 and the other sample was 400 words. So you can't really compare frequencies if your two samples are that different, okay? So in that case, you would definitely want to use percents. Otherwise, you would not be able to actually make a comparison, okay? So be careful of what your sample sizes are. If they are very different, you're going to want to use percents. More than likely, we'll use percents. It's almost safer to do that. Okay. And then finally, just because a graph looks nice, it's not necessarily a meaningful display, okay? So here's students in a small statistics class. They recorded the number of letters in their first names, okay? One student entered the data into a spreadsheet, and it's a bar graph, okay? This is a glorified bar graph, okay? Student 1, student 2, student 3, okay? The first name length is quantitative variable, so a bar graph is not an appropriate way to display its distribution. So the dot plot on the right would be a much better way. Okay, so just be careful of that. So we'll leave off with this kind of check your understanding problem. Okay. Just really quickly, so not too difficult. What are we looking at here? Okay. So is this a bar graph or is it a histogram? Okay. Well, a few different things, but I mean, the obvious would be that you have categories down here. Okay. They are all spaced out. So we're looking at a bar graph here. Okay. I feel like the biggest way to see that is these are categories here. Okay. So for sure, categorical data, it can't be a histogram. It's a bar graph. Okay. Would it be correct to describe this distribution as right skewed? Why or why not? No, it's not right skewed. It's categorical data. It's not quantitative. So you can't describe the distribution the same with categorical than we do quantitative. So we would not be able to say that this is right skewed. You would never talk about a skew for categorical data. Okay, and that's it with this video.